Good morning, everyone. We're going to start. Thank you for all for coming. I wish you have a lovely day and a very fruitful day with the amazing lineup of panelists that we have today. Our topic is cloud and big data and the correlation between them. And we have amazing speakers that I met at many events, and we're going to learn a lot from them today. So we're going to start with Ahmed Kushuk. He has 16 years of enterprise software sales and implementation experience. He works for Acquia. He's a business development manager for the Middle East and the MENA market. In addition to working with Acquia's customer, prospects, and partners, Ahmed engages in the Drupal community in the MENA region and structures activities to raise awareness of open source technologies in digital media. He holds a master's degree in computer science from George Mason University.
Assalamu alaikum, everyone, and good morning. This is a wonderful crowd, for a Thursday morning. Let's begin the presentation. As Ahmed said, I'm the GM for Acquia in the Middle East. Acquia is a company that provides cloud services, training, certification for anyone who wants to build amazing websites. And therefore, I have been exposed a lot to people considering the cloud, using the cloud, because for external facing properties, this is something that's very much useful. Next slide. So first, the subject of cloud can be confusing, and the term I sometimes use is fluffy just like the clouds. If you really want to have fun, I encourage you to go to YouTube and listen to Larry Ellison in 2008, 2009. There's some hilarious clips of him on YouTube discussing cloud. It's not just virtualization. It's not just software as a service. Everyone thinks that if you're using cloud, well, I'm using Salesforce, or I'm using Workday, or I'm using some application which I don't own. That's not cloud. And I love Larry Ellison's quote, it's not water vapor, it's a computer attached to a network. That's largely true. Anytime you access computing resources which is not exactly where you are using, in a sense, a cloud technology. If you remember John Cage from Sun Microsystems, which incidentally has been bought by Oracle, he's very famous for coining the term that the network is the computer, so much so that this became Sun's motto. And he was the chief scientist at Sun. So he opens everyone's eyes to the fact that computing resources are not just local. And if you use this idea, then you can actually extend this back to dumb terminals. If you're using mainframes and you use a dumb terminal, you're accessing computing resources which are not where you are. So luckily, the National Institute for Standards and Technology gave us a definition with the essential characteristics. These are the characteristics of cloud computing. Number one is on-demand self-service, meaning that the computing resources you use for your application, for your infrastructure, for what have you, can be increased by you on demand. This is useful, also sometimes referred to as elasticity. In this case, rapid elasticity is another essential characteristic, meaning that you can increase the computing resources very quickly. Resource pooling is also known as multi-tenancy, meaning that you can have more than one application, more than one user on the same computing resource. Broad network access is an essential characteristic. You cannot do cloud computing effectively if you cannot connect it to all the end users, whether this be on your own premise or in the cloud as it's known, the internet. The final characteristic is measured service, meaning that any person accessing the computing resources or any organization accessing the computing resources pays for what they use. There's the ability to do analytics and determine who used what. The next good definition or good taxonomy that NIST gave us are the service models for the cloud. The first one is the simplest and probably the one that most of you are using in some capacity today, which is infrastructure as a service. It turns out that someone like Amazon realized very quickly that all the investments that they made into their data center, security, reliability, scalability is rather large. And they said, hey, why don't we make this available to others to use? In fact, Amazon is our cloud provider of choice at Acquia. We build all our services on Amazon. But they're not the only one. There are many more. Rackspace, Google Platform, and I'm sure if you're a Microsoft fan, you know Azure and others. In fact, Azure went a step further by not just providing you the hardware and the network and the power and the storage, they actually gave you a platform. Here's the operating system with the database, here's some managed services for you. And if you use Google, there's the App Engine. If you use Salesforce, there's Heroku, there's Force.com. And our very friends at Oracle, of course, have their own Oracle Cloud, where you can deploy and develop Oracle applications using their platform. The final tier is software as a service, and this is really where everyone thinks the cloud is. On-demand applications to start. Salesforce was highly successful when they entered the Salesforce automation market, and now they're expanding. NetSuite is very famous as well if you want to run your applications, your HR, your finance, and Acquia as well in the services that we do on the cloud. And now for the deployment models that are possible. If you're accessing computing resources that are shared by anyone in the public, such as Amazon, such as all the ones that we mentioned on the previous slide, this is public. If you run cloud technology, virtualization, measured service, elasticity, in your own premise, this is a private cloud. Of course, there's the possibility of having a hybrid cloud, where you have the technology locally as well as externally, and you can leverage the resources in both locations. And there's a community cloud. Some governments are doing this. I think, in fact, the CIO in Bahrain has the possibility for other ministries and organizations to use their cloud, and it's only for this community of governmental organizations in Bahrain. Other deployment models will arrive. Distributed is the new, let's say, nomenclature for grid computing, and there are frameworks out there that will help you deploy your computing resources in a distributed manner and still use them. Some technologies that come to mind are things like BOINC, if you're familiar with it, or Hadoop, where you can distribute the problem using the MapReduce theory. And finally, there's the controlled cloud, sometimes also known as the virtual private cloud. So as you can see, that the essential characteristics of the technology can be applied in various models. So what are the drivers and benefits? I can tell you that this slide looked better on my computer than it does here. Any organization, when they're considering any new technology or any initiative, typically look at cost, time, quality. That's their basis. With cloud computing, you're looking at the challenge of CapEx and OpEx. If you can have an on-demand start, then you don't have to make upfront investments. Of course, by being more efficient, you're getting closer to green computing. I can't tell you how many times you go to a data center and someone in operations says, yeah, our average CPU utilization is under 10%. That's usually a flag that you're not running efficiently and that you could benefit from virtualization and cloud computing. Self-service is a benefit for you and for your users. The flexibility and agility that you get are arguably the strongest drivers for using the cloud, is that you can quickly shuffle your resources to do whatever project you want to do. You don't have to wait 2 months until you acquire the hardware and set it up. And if you use a cloud platform which is in the public, you're letting the experts handle it. At Acquia, for example, we have a 99.95 SLA, and I can go in length with you at what's required to reach that. If you try to do this on your own, you're looking for a big investment. And of course, another driver and benefit is that you pay only for what you use. This is something which is useful so that you don't have to acquire full stack and only use under 10%. The environment in the Middle East is actually friendly to the cloud. If you take a look at the broadband penetration rates, they're quite good. This means that your users can access computing resources remotely, and that's what the graph you see there on the right is for. This is the penetration, either broadband or non-broadband, mobile and non-mobile for broadband. The users have all sorts of mobile devices they want to use, and because they use social network on a daily basis, they expect to be able to access all the information and applications and business processes in the cloud. The major concerns and reservations I've seen in my experience in this region of the world is security, security, security. This can be a rather sensitive subject, but we don't really like to trust our data with anyone else. The sad part is we don't have a great track record. At the end of 2012, there were some very high-profile breaches and failures. And this is slowly changing, where people are beginning to trust the security in cloud technology. Reliability is a concern. Customization, if you're trying to use something in the cloud, it's really not one size fits all, so how easy is it for you to make customizations? And finally, integration. If you're using an application or a platform on the cloud, how well does it integrate with your on-premise solutions? Diving deeper into the subject of security, whenever this subject comes from me, I tell my prospect and customers, these are some of the certifications that we do, and we do it on a regular basis. How much investment would it take you to implement them? This is especially important if you're doing e-commerce. So my customer base is media, entertainment, publishing. Those guys, their business completely depends on being online. Reliability is another issue. If you're going to implement your own cloud solution or use someone else's, you care very much that this solution is going to be up 24/7, that you have backups. In fact, we take it a step further in Acquia, and I'm sure if you build your own cloud solution, you should consider this as well, where if you deploy to one data center, let's say in Bahrain, and then, Ahmed, I'm sure you remember, 2008, 2011, massive failures, loss of network, loss of connectivity. If you're a global organization, if you're a media organization, for example, you're offline, and this is catastrophic. One of the things that you could do, and that we are doing, is this hazard recovery as a service, where you have 2 data centers, and the 2 data centers are synchronized, and if one fails, one takes over. This is a wonderful benefit of cloud computing, this flexibility. If you're building the infrastructure are as follows, you have to take a look at the typical things that you do when you're building a data center, but you have to add things like monitoring, analytics, intrusion detection, the scanning, the platform itself for the cloud. And I'm sure a lot of vendors have approached you both for the software that makes the cloud possible as well as the software that runs on it. So maybe the question on everyone's mind is, should I use it? Well, you can only ask yourself that and answer that yourself. What are your objectives and needs? Which service model of the cloud you think will be useful to you, and which deployment model, and what resources do you have? If you're an IT organization with small resources, does it really make sense for your developers to build that expense application? I want to say 80% of the software used at Acquia, I mean, we're a cloud company, but the software we use ourselves, 80% of it is in the cloud. I access everything remotely, we use Google Apps, and it's very, very convenient. And above all, which processes and applications will you use? What is the level of standardizations for your process and applications? What is the level of integration for your process and applications? So here are some candidates. I'm not liking this too much. If you have spiking or seasonal load, that's a good candidate for deploying something in the cloud, because you don't want to make a huge investment in computing resources only to use them occasionally. Case in point, if you're having something externally facing for users or for your data. If there's a low need for integration with your systems, that's a good candidate or a reasonable candidate for the cloud. If you want high accessibility, if the importance to your business to have this reliability for the service is high, I would encourage you to consider the cloud. And finally, the speed of delivery. Remember, with the cloud, it's almost turnkey. You can start much quicker than you would do on your own. Very good. So I thank you very much for your time. I hope this introduction got everyone warmed up. And I'm very excited to hear from Rafi and Dr. Jassim about the case studies. Thank you.
Thank you, Ahmed. An interesting presentation. I'm going to ask you a quick question. You mentioned something about spike and handling the spikes. From an example we had a couple of years ago when London hosted the Olympics, and for the first few days of the ticketing sale, especially before the event, they went to the cloud infrastructure so that they spiked all the power they need and all the servers they need in order to handle the cater. Do you have any other examples you can give us around that?
Absolutely. So in the UK as well, they have the Brit Awards, something like the Oscars. Calm all year, and then one night, absolutely massive, huge spike. They happen to be a customer of ours, and sure enough, every time of the year, we work with them to make sure that they have the sufficient capacity to handle the load that comes. Another unfortunate example is the Boston Marathon bombings. If you were paying attention to that, you'll notice that some organizations covering this went down. Of course, some were covered with us, and we made sure that they were able to handle the spike. And examples abound, even in the Middle East. If you take a look at another Arab Spring type event, if you're in those sectors, then you will experience those spikes with reasonable, usual
unusual balance loads on the systems. Yeah. All right, perfect. Thank you very much. Our next speaker is Rafael Marti, is one of the world's most recognized authorities on security data analytics. Rafi is the founder and CEO of Pixel Cloud, the next generation data visualization platform for big data. With a track record at companies including IBM Research and ArcSight, he is thoroughly familiar with established practices and emerging trends in data analytics. He has served as chief security strategist with Splunk and was a co-founder of Logly, a cloud-based log management solution. Author of Applied Security Visualization and frequent speaker at academic and industry events. Rafi is a leading thinker and advocate of visualization of unlocking insights into data. For more than 14 years, he has lived in the security and log management space to help Fortune 500 companies defend themselves against sophisticated adversaries and train organizations around the world in the art of data visualization for security. Rafael, please. Thank you.
Good morning, everyone. What I want to do is kind of bring together three topics: the cloud, big data, and security, and kind of continue from where Ahmed left off earlier. So if you go to the next slide. I don't think it's going to work because it's I think you have to advance me manually over there. All right. So I'm going to talk about these three topics. I want to continue sort of where we left off a little bit with the cloud. I'm going to talk a little bit about big data, and then I'm going to talk about security a little more in depth again, and sort of what are the trade-offs if we move things into the cloud. So this is basically what we've already seen. If we look at the cloud, we get some very interesting properties, right? We get the elasticity. It's more effective, as Ahmed was saying. If you look at a data center, often, if you look at the utilization around or across the machines, you will see there may be 20% utilized or something like that. Something like the cloud can help you through virtualization to actually bring those utilizations much higher up and use those machines more efficiently. Another very interesting piece is sort of that redundancy. If you're building a cloud service from scratch, you're already architecting things with redundancy and failure in mind. So I know of cases, if you look at some of the bigger organizations out there, Facebook or Netflix or something like that, they actually shut down individual machines randomly. They have thousands of machines that are all doing the same kind of workloads, and every now and then they just shut down a machine. And that's their way of making sure that everything is fault tolerant. So any number of machines, not any number, but a number of machines can go down at a time, a hard drive failure, a CPU failure or something, and the system still works. And that's a great benefit that you gain by architecting cloud architecture, by already building that into the architecture of things. It also has to do with automation. It's when you're building a cloud infrastructure, you automate a lot of those things. I can today bring up an entire stack of our product in the cloud by the push of a button. It's all automated. There are scripts running. It will instantiate an entirely contained setup of our infrastructure. And I can replicate it multiple times, so it's all automated, and that's a nice thing because if something goes wrong, I still have those automation scripts and I can bring things up very, very quickly. If you look at the business case for the cloud, all kinds of very new models have become possible because suddenly you have access to large compute and large storage, and maybe even for a small amount of time. If you, 10 years ago, wanted to do some very complex processing or analytics on some data, you had to buy all those machines that were very, very expensive, and then you used them maybe for a day or a week or a month, and then you were done with your computations. You didn't need those machines anymore. Today, in a matter of a minute, I can spin up 1,000 machines that are going to be at my disposal for the next hour to do some data crunching. I pay for that, and then I don't need them anymore. I shut them down, and that's it. I don't have to make a big investment into those workloads. Now, what does cloud have to do with big data? If you look at what happened with the cloud, one of the things that happened is, A, compute has become fairly cheap, and it has become on demand, and storage is incredibly cheap. If you look right now on Amazon Glacier, you pay a cent for a gigabyte of storage per month, which is really not that much. You can store very large amounts of data for actually fairly cheap. Now, if I look at big data, for me what that is, it's basically a number of technologies that help me deal with large amounts of data. There's all kinds of things that I want to go very briefly into a little more detail. If you look at big data, there's a very interesting technology that are search engines. And if I say search engines, you probably think of Google or maybe Yahoo or Bing or something like that. But search engines are actually very, very useful for a lot of different things that you're doing in your own corporation. I'm going to go into that in the next slide in a minute. There's also the whole movement of NoSQL, NewSQL, key value stores. There's all kinds of things you might have heard, like Cassandra, MongoDB, CouchDB, HBase, Hive, all these kinds of things, where people have found new models instead of relational databases that we've had for decades now with things like MySQL, Postgres, Oracle, MS SQL, and so on. There's new storage models that are a little more flexible to deal with certain types of data that we have. And then, obviously, what everybody's talking about is the big Hadoop thing. Usually what people mean when they talk about Hadoop is really MapReduce. And the interesting part here, it's really not that new. We had parallel computing for a long time and high HPC, but what is kind of different is that back in the day when we did parallel computing, you had to take the data from somewhere and you brought it to those big clusters to do the computation. Today, we're doing it a little differently. We're storing that data on our commodity hardware, and we're pushing the processing to those machines. There's an interesting quote that I found. Unfortunately, I don't know what the source was anymore, but memory has become the new hard disk, and hard disks are the tapes of years ago. I find that fascinating. If you think about what that means, right? The amount of data we can store, and think about what that means in terms of building software. Now that you can have gigabytes in memory. I have a couple machines at home right now that have 256 gigabytes of RAM. Think about what I can do with that. I can compress my data and probably put a terabyte of data into memory. That's incredible what I can do with processing suddenly. So here's a couple of examples. The first one I want to show you is a big data stack for search. Here you have all kinds of questions you can ask to your data. Show me all the documents mentioning Pixel Cloud in them, for example. Or which documents contain the most relevant information about Bahrain, if I have a data store that might talk about it, Wikipedia or something like that. A typical stack looks like something that I have here. You have your raw data, the documents themselves. And documents can be log records. It could be XML documents. It can be Word documents, PDFs, whatever you have it. You use one of these search technologies, and these are both open source technologies, and they're absolutely commercial grade, used everywhere for all kinds of different services. One is Elasticsearch, the other one is Solr. What they basically do is they take the documents and create an index so that you can very, very quickly retrieve the data that you have collected. And there's different ways to access that. From an interface perspective, you can have web interfaces that are built to look at that, or you have REST APIs to do more programmatic access. If you look at another use case with large-scale processing, this starts looking a little more complicated. I have two stacks here, one on the left, that whole stack there with Tableau, and then the other one on the right-hand side with Shark and Spark. So what we see here is basically if you have a question that's a little more complicated over a large amount of data, and you want to say, visualize my user activity that I collected, cluster that behavior based on different user groups. So if you have a big website and you want to figure out do I have different types of users that are using my website in different ways? This would be a stack that you can use to do that. On the bottom, generally, you have this HDFS, which is the Hadoop file system. It's a distributed file system that you can run across different machines. It's almost like NFS or something like that, if you're familiar with that. Then you have that MapReduce layer, which basically allows you to do large-scale processing in a very parallel fashion. And the traditional way that a lot of people are aware of is Hadoop. On top of that, people don't like to program in MapReduce ways. It's a hard way to think about it that way. You have to sort of learn how to program that. So what people started doing, or companies, is they built a SQL layer, an SQL access layer to that data. And there's all kinds of projects. The hot things are Impala right now from Cloudera. There's Stinger, there's Hawk, and there's a couple of others that are allowing you to basically use SQL to access the data. Now think about that for a second. SQL is the lingua franca of accessing data. And now we are able to access big data in that way. That's an incredibly important thing to remember. The next layer on top of that are analytics companies, and it actually starts getting really sparse if you get up here. There's a couple that I mentioned here. There's many, many, many more, but two that if you are in the if you're looking at analytics things, check out Hex Data and Revolution. And then on the visualization side, you basically take this analytics and you want to show that in a way that people understand. And there's a bunch of companies out there. One that you might be familiar with is Tableau, that lets you visualize a lot of that data. Now the right-hand stack is probably something you've never heard of. Has anyone heard of Spark, the whole stack? No? It's something that comes out of the Berkeley labs in California. Berkeley is famous for building databases. They have built the Berkeley DB, one of the first relational databases back in the day. And they started building a much faster MapReduce framework. It's up to 100 times faster. If today you're starting a project in the MapReduce space and big data, I encourage you to have a look at it. Be careful because you need the people that understand how to use it, and they're a little sparse at the moment. Every PhD student coming out of Berkeley right now is making a good salary, so good luck hiring them. But it's a very, very interesting paradigm, and I'm happy to talk more after this. Now, there are limitations on big data, and I'm going to speed up here a little bit. One of the things that you will realize, if you have petabytes of data, how do you get insight into that data? I can store it, I can process it, but just because I can process it doesn't mean I understand what my data is about. So how do I do that? And there's a multitude of challenges here. If you're familiar with the data science world, it's actually not easy to process a petabyte of data and figure out what's really interesting in there. How do you cluster that, and so on. So keep in mind, big data is not always just a solution to your problems, but sometimes it also creates new problems. Now, let's take a quick step back again and look what has changed. And this is something that Ahmed was already talking about in his presentation. Keep in mind, in the data storage and access world, we have a couple of things that we have to overcome when we start using the cloud with privacy laws, with data retention issues, and so on. On the processing side, very similar, suddenly we have hypervisor issues, right? You might be running your workloads on the same machine that I'm running my workloads on. Now imagine if I find a way to escape that hypervisor and look at your data. Or what happens if I just use the CPU of that physical machine, and if there are not clear boundaries, I might use your CPU as well. That's not very nice of me, I know, but it happens in the cloud. Now, if you look at its security for the cloud, how I would define it is the risk that you're taking is sort of a function of threat and vulnerabilities. And there's a couple of threats. There's definitely not all of them, but a couple of things that you might want to think about is you have shared resources that could be a threat to you. You often start using external services. If you're on Amazon, you will probably use a bunch of their services. There's anything from the relational database you can use their DNS servers. You're probably already using a DNS provider. I don't think that many people are running their own DNS anymore. If you do, you probably still use an upstream DNS somewhere. Maybe you have a hosted secondary DNS somewhere. So you have to rely on these third-party services. What does that mean to you? What's the risk of that? What's the risk of their availability? What's the risk of confidentiality and over there? On the vulnerability side, if you're using cloud services, you are at the mercy of your cloud providers. I'm not sure if you have followed in the last couple of days, there was a new bug that came out in the OpenSSL library. a lot of internet services were vulnerable to something called Heartbleed in the OpenSSL library. It was possible, or it still is, if you haven't patched your machines, I would encourage you to walk out of this room right now and do that. It's an incredibly severe vulnerability where it is possible for remote people to access credentials, to access your keys in memory even. So it's a very, very severe vulnerability. And if your cloud provider has not patched their machines yet, you might be in trouble. So keep that in mind. If you're using a cloud and you have an audit that you do, a PCI audit or something like that, often a lot of the things are not under your control. How do you actually remediate these audit findings? Can you work with the cloud provider on those? Do they even react to you if you go to them? Those are some things that I would encourage you to keep in mind. I'm going to skip over this because I'm taking way too long here already. So to basically sum it up, what we're doing at Pixel Cloud with my current venture is kind of taking those three things and combining them a little bit. We're building a way that you can take a large amount of data and process it and to find insights into the data through visualization. And this is the one way that gives people a very interesting interface to data to look at it and understand it very, very quickly. We're using the cloud as an intelligence capability where we're collecting how people are visualizing their data. We're not collecting their data per se, but we're collecting sort of their behavior and say, okay, this is how people look at firewall data. This is how people look at their marketing data. So we learn on how people are using that and leverage the cloud as that sort of intelligence piece to that. And that's how we're trying to help companies become more secure by allowing them to look into their data and starting to understand what is really happening in their applications and in their environments. And last but probably not least is this kind of can help you turn security into a profit center. And this is a thought I want to leave you with. Is there a way that security is not just a cost center that people have to push money into and basically have you remediate problems, but how do you become a profit center? And I think the cloud and big data is a very, very nice way to do that, because if you're collecting data for security purposes, for monitoring purposes, there might be a way that you can offer that data back out to other constituencies, product management, marketing, in your company that can benefit from that data. And if you give them analytics on top even, there's even a better return on investment on that. And with that, I'm going to stop here. Thank you.
Thank you, Raphael. The thought that you left us with, I want to come back to you at it. You said security is a profit center. Now, I'm sure that's something we share with everybody in this room, that everybody sees IT as a cost center in general. And we're hoping that the most of the cloud would be something that would make, would change that perception that IT is supporting business. But how do you relate that? Like, how do you turn an IT, environment, an IT department to a profit center using a few small steps by integrating like cloud, big data, and all these new trends?
I'll give you a couple of examples. One for how security can become a profit center. I've worked with a bunch of companies lately where we looked at their log management infrastructures, and we realized that the different teams, networking, system administrators, Windows teams, and security, they needed access to the log files from routers, from operating systems, and all these kinds of things. And there was a constant finger pointing. If a machine didn't work, the sysadmins would say, oh, the network is the problem. The network guys were like, no, 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 it's the systems themselves. So what we instituted was this message bus, where we put all the logs into one central storage. And as a security team, we ran that project, and we offered it up to all the other constituencies to access the data and look through it. And that was a great enabler for everybody. A lot of time was saved because they don't have to collect their own data. They don't have to go and ask other people. So that's on the security side. Now, take this example and spin it a little further. You're collecting your web server logs for all kinds of purposes. You might look at vulnerabilities or like potential scanning activity. You're looking for people breaking into your systems. Now, the web logs have a lot of value for marketing. So, well, okay, make that data available to your marketing teams and give them access to it. And if you can convince IT to build a couple of tools that they don't have to use the raw data but actually have some nice interfaces, that's a huge win. And suddenly you're back in the business. Those are the things that I would look at, and big data is definitely part of that.
Oh, great, thank you. Now we go to our next speaker. Dr. Jassim Haji. He worked with Gulf Air, has been instrumental in implementing some key innovations at Gulf Air's IT system and processes in recent times, most notably the introduction of advanced technology for Gulf Air worldwide contact center and cloud computing that have helped further improve customer interface services as well as cost efficiency of the company. Dr. Haji received his doctorate in business administration from University of Northumbria at Newcastle in 2010. Dr. Haji, please.
Assalamu alaikum. Good morning. Bismillah ar-Rahman ar-Rahim. I would like to take and conclude this session of presentations by showing you some of tangible and real results of cloud computing and big data. This is a case study of Gulf Air for the past 3 years and how we implemented private cloud computing and a big data in Arabic sentiment. And I will explain to you a bit later how these are unique in terms of innovations in this part of the world. All right. It goes back. Okay. Of course, as an airline, we have demands on dynamic basis. The airline industry, just for information, in this part of the world is very competitive. We nearly have 15 airlines in the Arabian Gulf. You find one airline in the whole Scandinavian. So to keep up with our neighbors, and we are, of course, flag carriers of Bahrain, founded in 1950, 64 years ago, one of the first in the Middle East. Obviously, Bahrain is very well known on its innovation and its people. And this airline, as we move on with it, rely a lot on technology and its people. One of the key challenges in the past few years was, when you are an airline with computing which goes back to 1970s, and you have an infrastructure that is not easy to renovate. I mean, it's much easier if you build a company tomorrow and put it in the cloud or data center, mainframes, servers, whatever you like to call it. For us, the decision to go to the cloud was to provide a platform to globally serve over 150 cities around the world, connect them to your headquarters, and also bring your aircraft into the cloud as well. So later I'll talk about it. That's the cloud of the cloud, I call it. We had to move very fast to open stations, close the stations, increase frequencies. And how do you do this when your competitors are working somewhere and then you want to catch up with them? You can't wait to establish an infrastructure. You had a high IT budget, which sometimes uncontrollable, with vendors keep increasing the licenses, the hardware costs, etc. And of course, this is for them to do. You needed a disaster recovery center, a business continuity, which is very crucial. You can't stop the business. And a mobility to provide, most importantly, to customers. Flexibility to be able to check in, view bookings, do whatever they like, wherever they are. And that's how you grasp your business, because you can't wait for them to come to your ticketing office or wait till the better offers are on the table from other competitors. Or if your system is slow or down, this will lose you a lot of opportunities. So again, going with the cloud, there was a decision, do we go with the private and public cloud? Knowing the schema of the vendor management in this part of the world, we had a theory, if your business is big enough and you want to control it and you want to maintain it and enhance it, private cloud is the way to go. Private cloud was, for us, more cost effective. It was something that we take control of it in our own hands. And also, understanding the business, we could address all the security concerns. Public cloud, to my personal opinion, is adequate for smaller companies. I mean, if you have more than 3,000 or 4,000 PCs, you can't, when you put it on the public cloud, what it means, and this is where the vendors get it right, they take you from your infrastructure, dismantle it for you, put you on the public cloud. And what you have nothing. And you have a contract for next 3 to 5 years, and you have no other choice but to continue with them. Because to go back and establish your own data center and a private cloud is going to be a mountain to climb. So for us, that was not a choice. Although integration between private and public cloud is also is pivotal to the business. But I think smaller companies, they cannot, or it's not justifiable to spend a lot of money on building their data center. Public cloud, as the gentleman says, on what is available today is the right way to go. Of course, building your private cloud is not an easy task. You need all the expertise that you have, because unlike the vendors who support your public cloud, or so-called public cloud, you need to maintain it, and it's very complex arena to do so in terms of configuration, network management, the whole cloud management, security, etc. And we chosen the best of the breeds. We didn't go with, for instance, end-to-end vendor X or HP or Microsoft. So we taken, for instance, virtualization with VMware, and we did a database consolidation with Oracle, and so on with data compression. One of the challenges you have with cloud, of course, is an airline like us, where you fly to different parts of the world. With all the respect, when we went first to Iraq, for instance, the internet speed is disastrous, and as a remote connectivity, you rely a lot on that. So when there is instability, when there's a speed limitations, you come across that, but you have to mitigate it. Whereas Europe and other parts of the world in the Middle East, they are more reliable and probably more cost effective. So again, in the reality, in terms of numbers and percentages, the result of the private cloud installation, which, by the way, we were the first in the Bahrain, and one of the first in the Gulf as well to implement it. Of course, one of the first airline to do so, helped us to reduce our cost by 41% on the capital. The relocation of the people. What happens is, when you have certain physical servers or storage, after a few years you need to refresh them anyway. But that number keeps growing because the real life is no more than 3 years. So what we did, we got rid of the old legacy servers, but instead we refreshed the current one with, of course, using the virtualization technology, and of course licensing and other means that are part of the entire data center infrastructure greatly reduce our cost. So what you do effectively, get more out of your infrastructure or out of the cloud by spending less. And to me, this is one of the beauty of the cloud, because when you go to the CEO of the company or your board, they don't care if what you have is called cloud or is called server or is called mainframe. But these figures, these reductions, efficiency increase, less number of people you require, on the legacy systems, of course, there are lots of technical interventions required. But here you require higher skilled people, but the lesser in the number. The availability, I think the gentleman says 99.9%. We managed to get it 99.7%, which is very high in terms of data center availability, considering the links that you have around it. And of course, we've also integrated our disaster recovery center with our main data center to make them all part of the cloud. And that was the platform for the business intelligence, big data, the route vision, which now the airline is greatly, well, all the airlines are greatly relying on the information on how to make right decisions with information and spontaneously that's available on your dashboard. All the CEOs want to see this. They don't want to see the bad news or the good news in weeks. They'd rather to see it in minutes. And one of the things I mentioned earlier is a cloud of the cloud, or cloud within the cloud. All pilots need to carry their manuals with them, and that's a regularity by IATA. What we have done is replace them all with, for instance, iPads, and they are connected to the cloud. There is a connectivity, so you know you have a control over your aircraft. They have communication with the ground and more effective use of data. That by itself, I mean, it saved us $1.5 million just getting rid of the paperwork. And I'm not even talking about the efficiency that has increased. So, of course, we have the virtual cloud on the ground, and we have the cloud in the air on the rainy days. Now, I don't want to go into more theories of big data. I think the gentleman here has explained it very well. But for us, the social media today is the way. You know, most of your passengers, or maybe 60–70%, are youngsters and people using social media. You know, those days are gone that you probably advertise in the streets or in the newspapers. Those days are gone when you communicate by sending a letter to the company and start complaining. So social media is where you want to understand the potentials. I mean, we as an airline want to know where to open a route, for instance. You would like to analyze the feedback from your customers, different parts of the world, on what they say. So there's a potential in, I don't know, in Jakarta to open a route by analyzing the demand on the air traffic from that part of the world. If you want to see what are areas of service improvement, you want to see your passengers, where they're complaining, where they are giving you a more, hint on that. So, of course, again, seeing the options of the, big data was the three that is usually available nowadays for people to choose from. And since we had established 3–4 years ago a private cloud, and this is a platform that you can build on and address the growth. So again, this part of installation was done by our own people. These are all, by the way, young Bahrainis, men and women who graduated from school. They had the basics, and they went, have done their own R&D over 9 months to be able to come up with this solution. The beauty of it is that when you build it, the customization, the enhancement is done with in-house development and without involving third parties. Where upon the completion, you will start understanding the loopholes that you will go through, with the documentations, with the requirement to maintain it. Now, sentiment analysis that we were unique in is about, and it's a very difficult topic to handle. It's not written in plain English or Arabic to say what your customers actually want. It's based on feelings, attitudes, subjective responses that you get from your customers on the social media. These are the sales opportunities. This is how you can communicate with everyone around the clock. Of course, um, now we are a regional airline. We are working in the Arabian Gulf and the Middle East. We have many customers who are Arabic speakers. They communicate in Arabic on social media. They take word of mouth. The translation from English to Arabic is always not literal. So you need to communicate with them directly. And we said 80% of the post related to us as Gulf Air and probably airlines in this region is in Arabic. Of course, for us, it was English sentiment is available, and many people have done it. But Arabic, through the researches I personally done, no one has ever done it, not only in the Gulf, but I haven't seen it anywhere in the Middle East or probably other parts of the world. So working with that, and the difficulties that you in Arabic, of course you have different dialects. You know, mother, shunu, shu. I don't know. In Bahrain we have different shu. So that goes without saying, you know. You have to put all that in your vocabulary. So we had to have our own Oxford dictionary of Arabic to be able to translate it. And if you don't, you know, you probably get the wrong analysis out of it. You will not get it 100%. That's why we had the margin of errors, but majority are a reflection of what your customers want. You know, these are some of the things that analysis have taken a very high level sample of what we do. But the accuracy, as I said earlier, is not 100%. We think we are 80% there. The target is to get obviously more. But the results have shown also the increase in the sales and the demands on the potential. You know, when you have your data on the business intelligence through different statistics that you get from IATA and others, and then you combine it with your customers, that will give you a pretty good picture of what you have to do and how you can advance others. Today you go buy a ticket, you know, there's a difference in 1 hour and 2 hours. The ticket price is going up and down. It's even worse than a stock exchange. So now, again, as I said earlier, these are some of the benefits that we did. It's like marketing, advertisement. You cannot put your finger and say, this is how much I saved. But you can say, you know, overall, how the trend has gone up, how the customers are feeling, how they feel that you are listening to them. Arabic sentiment for us was a start, but it doesn't mean that, you know, multilingual, big data on sentiment is not impossible. Probably you can have the same things in, I don't know, Malayalam in India, or you have Tagalog in Philippines, or something else. So for local people to understand where you're coming from and how you communicate with you. Although English is international understood language, but in this region we rely a lot on our native communication. I think this is it. Thank you very much for listening to us, and hope that was a useful business case for you. Thank you.
Thank you, Dr. Haji. I always keep one question for every speaker, and the one I have for you is, the year before you went to the cloud and the year after, what was the one thing that you saw it and you were very happy about, like doing that change that we encourage all enterprises to go for? If you just would choose one thing, regardless if it's related to business, because you showed where we stopped at the last question, how to transform IT as a profit center in a way, but what would be that thing?
Let me say something. I don't know if that's true everywhere, but we in Bahrain has always been entrepreneurs. And I think it's a blessing, I'll take a different angle, from God, that probably we don't have that much natural resources in this country. And we always have to come up with innovations and creativity to be able to be among the front runners in this part. So one thing we have in technology in Bahrain that our probably neighbors don't have is the reliance on the people. And when you go through tough times, with the competition, with sometimes on losses, you have to find out other ways and means to come out of that. I mean, through the financial crisis in Europe and States, there were many solutions that came out, whether it was on the banking side or the monetary, but that was a result of the pressure. And I think sometimes the business competition has given us this leverage to go and come up with solutions that reduces your cost, but at the same time be competitive and increase your efficiency.
All right, thank you. I'm going to open the questions to the crowd. Like, does anyone have a question? Please raise your hand and we'll send a mic to you. Is there any question?
I have a question for Dr. Haji and Raphael, separate questions. Dr. Haji first, I'm quite glad to see an example of a private cloud establishment and a successful success story about that. Especially you have done it with internal knowledge and expertise, or developing internal knowledge and expertise. In your case, you said, though it's a private cloud, you still saved significant costs, capital costs in the first year of implementation, when that is quite substantial. My question is, having spent quite a bit of money on establishing your own private cloud, how did you make that possible, saving 40% on CapEx costs? Is it because you avoided duplication of establishing servers and softwares in each division and function, or so on, or any other factors? So that's...
Well, the key is that we did not spend substantial amount on the private cloud. It's when you design it, and as I said, you pay less and get more, and that's the challenge. I mean, today, you go to any organization and tell them you want to implement cloud or any latest technology, they, bring any vendors and that will, that'll be done for you. But the irony here is how you reduce your cost and implement the latest technology. And the cost savings, as I said earlier, was, the more you get into the cloud, the more of sharing of resources. I mean, the sharing of resources is the key, I think, in terms of software licensing, in terms of bandwidth, in terms of your storage, your processing, your memory, etc. So that has also not only reduced your cost, but your potential expenditure in future, because you have certain capital every year as an organization put on one side to refresh your infrastructure, your backbone, and if you don't, you will risk your availability going lower, and the SLAs, etc. Of course, one of the things that you have to take into consideration by going there, there are more threats that you have to mitigate. You don't know. For banks, for instance, is a bigger issue. Where is your data now? They have regulations that the data has to be within the country. You cannot go out. When it's in the cloud, what is your country? Is your country here, or is it anywhere in the part of the world? And there is no today standards on the cloud computing. Unfortunately, this is one thing that's missing.
Thank you. This question is to Mr. Raphael Marti. We, as a university in the UK, one of the universities, we work with some large organizations, but also with small and medium enterprises, SMEs. Now, how big the data has to be to qualify for a big data? Because a lot of small companies think that, well, big data is not for us, even though some of these companies have 500,000 transactions in a year or two, commercial transactions. The reason I'm asking that question is, you discussed some of the challenges with data mining, the traditional data mining techniques, and also discussed a few alternatives. So the big data, the visualization, data analytics, which work on big data, the latest stuff, could SMEs use it? If they can, what way? You know, that's.
So I don't want to give you a definition of what big data is, because it's going to vary on different people. I don't think it matters that much. I think what really matters is, what are you trying to do, and what is the data that you have? I had a conversation with someone here at the conference, and he was telling me that he was going to use, I don't know, some big data technology to do some data processing. And I said, well, why would you do that? Why would you spend that much money on this one solution? Let me understand your problem better. And I asked him, what's the data that you have, and what are your use cases? In the end, I said, based on what you're telling me, probably the right solution is use MySQL, open source, relational database, very old, but it scales. Facebook is using MySQL for a lot of their data processing stuff. There are some challenges you have with traditional relational databases. But for certain problems, that's the right thing to do. There's all kinds of considerations that go into what technologies to use, like can you find the right talent to actually deal with it? Like, I'm amazed that you guys did it all in-house, that you trained your own people. I think that's fantastic. Because today I can't find, in the Silicon Valley, in San Francisco, I cannot find enough qualified big data people that understand Hadoop. So the right approach is to train these people yourself, but it's an opportunity cost, obviously. So I'm not sure if I answer your question to this, but I really strongly believe, look at your problem, look at the data that you have, and figure out what the right approach is for that.
To all the three panelists, why there is so much resistance to big data? We all know that it's so important. We know that it brings a lot of benefits to the company. Why there is so much of resistance?
Over to you.
Is it resistance or hesitance? Resistance.
I would prefer them to answer that.
Right.
I'll give it a try. Okay, so with any new technology, with any new concept, there's a couple of stages that people go through. So you have the early adopters. The people say, this is cool, this is wonderful, I want to play with it. And then you have, those are the guys on the bleeding edge, really like technology. Then there's a phase, there's a very good book called Crossing the Chasm, and that's the phase when the early adopters have been exhausted. And that's unfortunately the phase where technology could die and even companies could die. After this phase, you enter the so-called Main Street, and then even in Main Street, there are the early adopters and the laggards. And that looks like a bell curve. And then finally you have the people who will never ever stop doing things completely on their own or doing things completely the old way, hyper-conservative. It's just a natural law of change, that maybe you have people who take the risk early on, then you have 80% of the people who eventually and gradually use it, and then you have people who will never drop their Nokia 51. They don't want a smartphone, they don't want to use cloud. I think that's normal, and we'll continue to see that with every technology.
I completely agree with you. Look at the term cloud, right? A lot of people resist it in the beginning. But I want to take another stab at it. If you look at the big data technologies out there, it's a mess. If you have a big data project right now and you're trying to find the right technology to use, oh my goodness, I don't envy you. There's so many different projects, right? If you need a key value store, when do you really need a key value store? And once you determine that, well, what product are you going to use? Are you going to React, Cassandra, Couch, Mongo, HBase? I could keep going. What is the right technology to use? And then you ask a friend, and he's like, oh, you got to use this. And then the other expert says, no, we tried it, that doesn't work. So there's a lot of self-proclaimed experts out there, and you talk to some of them, and then it fails for you, and it's a mess.
I'll just add one thing, and I know vendors hate me for this, but I always say, when the new technologies, the vendors come up with scenarios where they trial and error on the account of the customers. So they don't know what they're doing themselves. And then they try it on you, and then the next customer probably get it better. So that's why we said, well, we'll try it ourselves. But at least we know, learn from our own lessons.
Thank you.
All right. Thank you, guys. Let's have a coffee break. Thank you guys very much. We'll see you back here in 15 minutes.